Hello students, in this lecture we are going to discuss about the procedure that we can follow in order to reduce block diagram, and later on we'll take a problem and solve it using the different rule that we have studied in previous lecture for block diagram reduction. Let's discuss about the procedure. So first step will be in a given block diagram problem is to search for blocks in series, blocks in parallel or blocks in minor feedback loop. So if we are having any of these, what we can do, we can apply the corresponding rule in order to reduce those block into a single equivalent block. If we are not having any block in series, parallel or minor feedback loop, what we have to do, we have to create blocks in series, parallel or in minor feedback loop. That we can do using by shifting summing point behind or beyond the block, or takeoff point behind or beyond the block. So by applying these rules, what we can do, we can create blocks in series, blocks in parallel and minor feedback loop. And once we create these blocks, what we can do, we can again reduce it to single block. Now we have to keep on repeating this step till we get a simple form. Once we got the simple form, we can find the transfer function of the overall system as C of S upon R of S, that is output upon input. So this is a procedure that we can follow. So what we have to do, we have to search for blocks in series, blocks in parallel or minor feedback loop. If we are having, we will be applying the corresponding rules to reduce it. If we are not having these blocks, what we can do, we need to apply other rule to create these blocks. And again, we can simplify it to get the simple form, and later on we can get the overall transfer function of the system. So let's solve the first problem on block diagram reduction. The question here is to find the transfer function C of S by R of S for given block. So in this problem, we are having R as input signal and C as the output signal, and then we are having various blocks which are connected in their logical sequence. And here we are having a different feedback signal also, that is ending to these summing point. So now let's reduce this block in order to find the transfer function of it. So first step will be what? To search for whether we are having any block in series or block in parallel or block in minor feedback loop. If you see carefully, this G1 and G4, they are forming block in series, and similarly we see here G2 and G3. So both signals are moving in forward direction and they are ending to a common summing point. So G2 and G3 are in parallel. So first, directly we can see here we are having two block in series and two block in parallel. So let's reduce it and then we'll move ahead. So first we need to create a summing point as it is, and we are having R as input to it. Then we are having next summing point, and after that we are having two block in series, so G1 and G4. And we know that whenever we are having block in series, we can reduce it to single block, and that single block will be having equivalent transfer function, and that transfer function will be multiplication of the blocks in series. So it will be G1 into G4. Next we are having these block G2 and G3 in parallel. So what we can do, we can replace them by a single block, and that block will be having algebraic addition of transfer function. So it will be G2 plus G3, and then we will be having output in the form of C. Now what is remaining, we will be keeping it as it is. So we are having H1 feedback which is emerging from here, so we'll keep it as it is. Similarly, we are having another feedback in the form of H2 which is sensing the output signal, so we are going to keep it as it is. Now after that, we need to again see whether in reduced block we are having again block in series or block in parallel or any minor feedback loop. So if you see carefully here, we are having G1 into G4, this block, and H1, they are forming a minor feedback loop. So we can reduce this feedback loop by its closed loop transfer function. So we will be applying corresponding rule to reduce this loop to single block. So again we'll be having R as the input to the summing point, and now this summing point and these two blocks will vanish and will be replaced by their equivalent block. So that equivalent block will be writing here, and it will be this transfer function, that is G1 into G4 upon 1. Now we have to see the signal. If you see a signal here, it is positive, and for this one it is negative. So right now we are concentrating on this minor feedback loop. So its signal is positive, so we will be having negative here based on the rule. And what else? It will be G1 into G4 into H1. So it is the closed loop transfer function of this minor feedback loop, which we got based on the rule. And next, ahead of it, we are having this block G2 plus G3, and then we are having the output, which is sensed by this H2. Now again we have to see whether we are having block in series, parallel, or minor feedback loop, so that we can directly apply those rule. So now if you see here carefully, this block and this block is in series. So what we can do, we can multiply the transfer function of both of them and we'll replace it with a single block. So it will be summing point, input signal is R, and then we are having a single block and it will be having the equivalent transfer function. It will be G1 into G4 in bracket, because now G2 plus G3 will be multiplied here, so of course it will be multiplied in the numerator. So we will be having G2 plus G3 on, and denominator will remain as it is, 1 minus G1 into G4 into H1. Then we will be having a output signal here, and again that signal will be sensed by block H2. Okay, now if you see carefully this one, it is a minor feedback loop, so directly we can replace this entire block with its closed loop transfer function. Okay, so it will be input signal R, and then we will be having closed loop transfer function of the above blocks, and we will be having a output. So how we write, let's revise the rule number 8. So if we are having a summing point, we are having block say G, and we will be having an output, and then it will be sensed by feedback signal. If we are having a minor feedback loop of this nature, so its closed loop transfer function will be C by R is equal to G upon 1. Now sign is important here. What is the sign of this feedback? So say if it is minus, so it will be plus here into these two blocks, so it will be G into H. So this is the rule number 8, that is removing minor feedback loop, so we can replace it by its closed loop transfer function. So this is the closed loop transfer function. The same way we will be writing closed loop transfer function for this block that we are having here. So it will be G1 into G4 bracket G2 plus G3 divided by 1 minus G1 into G4 into H1 upon 1 plus, because here the feedback signal is negative, so plus, and it will be again will be repeating the above block G1 G4 G2 plus G3 upon 1 minus G1 into G4 into H1, and here it will be multiplied with H2 because this is the feedback signal. So now we have reduced it to a simple form. So what we can do, we can write the transfer function here. So it will be C of S upon R of S, that is output upon input. So we can write in the form of C of S upon R of S, or we can simply write C by R, but better is to write always as C of S upon R of S. Then it will be G1 into G4 upon G2 plus G3 upon 1 minus G1 into G4 into H1 divided by Now here what we can do, we can cross multiply so that we can make base same, and later on we can cancel with the above denominator here with this one. So it will be 1 minus g1 into g4 into h1 plus this term here. So it will be g1 into g4 in bracket g2 plus g3 into h2 divided by, now base will be 1 minus g1 into g4 into h1. So what we can do here, we can simplify it. So this denominator and this denominator we can cancel. So we will be left with g1 into g4 g2 plus g3 divided by 1 minus g1 into g4 into h1 plus g1 into g4 in bracket g2 plus g3 into h2. So this is the transfer function for this block that we are having here. So now with this we'll end here, but before that let's revise. So we have started with the procedure that we can follow in order to reduce any given block diagram, and then later on we have solved one problem, that is this one. So with this we'll end this lecture.